So we're back here on the Honda Prelude block in the decking machine today. This is the opportunity we have here to deck the top of the cylinders where the sleeves stick up above deck surface, and then also cut this surface down to provide the proper finish, nice smooth flat surface for our head gasket to seal against. The machine I'm using here is a Rottler SM7. It's a manual machine, it's not a CNC. It is a CBN machine, so it has a cutter that is really hard, really dense, turns at a high rate of speed, and will give you an excellent surface finish, a beautiful surface finish. So let me show you what one of those cutters looks like. The one I'm using is going to be this one. This is the CBN cutter. It's just a little disc of metal, but it's a special metal, very dense. It has the outer edge, focus here. The outer edge of the metal is sharp, and that leads to the appropriate cutting surface to do this type of work. There are different types of CBN cutters for different purposes, so let me show you what some of the other ones look like. This particular one here is for aluminum. Maybe, hopefully you can see that better. Come on. So yeah, the cutting edge on this gold one here is a little bit more positive of a rake, which it's hard to see, I know, but basically kicks up at a sharper angle, and it gives a very smooth finish for aluminum. In our case, we have cast iron sleeves, so we're not going to be able to use that. We're going to have to go with the standard one, which will work excellent as well. And you'll see how this looks in a few minutes, where it mills it perfectly flat and gives a great surface finish. So I already have the block sort of mounted in the machine, and I've begun dialing it in. You have to level the block, both ways, this direction and long ways, using my dial indicator right there. I've been using that to level it in. I still have a few more minutes worth of work to get it perfect. So I'm going to go ahead and finish setting up, and then we'll be right back, and I'll show you exactly what this is going to look like. All right, so we're about to take a cut on the deck surface. So what I'm going to do is move the cutter head closer to the deck and go ahead and make a pass. It will get a little bit louder when we get into the cast iron sleeves, just because of the hardness of the metal is a little bit more so than the aluminum. So you'll hear a difference in sound and everything. But here we go. I'm going to go ahead and turn the spindle on, cutter head. I'm going to dial in about 4/1000 of an inch to start. Okay. And then I'm going to turn my feet on a pretty slow pace just to get started here. And then we can adjust as we need to. All right, we're already cutting aluminum. And you'll hear it start to cut the cast iron here in a second. so let's take a look at how this looks. Move the cutter head away here, and we'll take a look at our surface finish, see how this is looking. Okay, so it's starting to cut all the way across. It looks really good. There's some areas here that haven't actually touched yet, while this area and this area has started to touch. So you can see there's definitely some warpage. It looks like it's a little bit low through here. I indicated this entire deck surface in within about a 1/2 thousandths of an inch, so very accurately. So anyways, I got another pass, or maybe 2, and then we should be good to go. So I'm just going to keep working on this, and I'll let you see how it looks when it's all said. All right, so I'm on my second pass right now. We've just taken 6 thousandths off of the deck, and I wanted to stop for a second to show you what it's looking like. I don't know if you can tell the surface finish on this, but it is absolutely gorgeous. It's looking really good, and that's sometimes hard to do when you have an aluminum surface and a steel or iron surface next to it, because the chip of the iron as it's cutting will tend to drag across the aluminum. But everything's working really good right now. Our cutter is super sharp, so it's, you know, just leaving a beautiful surface finish. I wanted to show you why we had a problem. You can actually see it here while we're milling it. If you look, all of this is nice and clean and freshly surfaced all the way through here. All of that is beautiful. All the way around at this point is totally freshly surfaced. That's all new metal, or new surface metal. But down in the cylinders around the sleeve, it's still old and rough and, you know, unsurfaced. Now my sleeve is surfaced because it was sticking up a lot higher, but the aluminum around the sleeve, what was the original cylinder, is not fully surfaced, and you can see where it is right here, and then it fades away to it's not. The reason why that is, you know, and all the way around here, is what we're having is low spots in these cylinders. Basically, they're down lower than the rest of the deck, and you're seeing that in like a warpage, kind of a this direction warpage through the center. So a little bit here, and more so over here. But on this side, it looked pretty good. There's one little spot left right there in the middle. But yeah, so the number 1 cylinder here was probably the worst. Number 1 and 2 had some pretty severe warpage. And if it's severe enough, I mean, I've already taken 6 thousandths off of this, so it's beyond that another few more thousandths. I measured 8 with my straight edge to begin with, but anyways, if it's warped that much, then a head gasket can't seal that. That's just beyond the limits of what a head gasket can seal. All right, so there it is, all decked and ready to go. It ended up taking about 9.5 thousandths of an inch to clean all the way up. And that's okay, because I measured down to our little identification marks right here, and to begin with we had about 18, so that gives us, you know, almost 9, 8.5 or so. So we still have plenty of meat left before we run into any valve to piston clearance issues, or piston to cylinder head issues, or any other thing like that. Also, the compression won't be too drastically affected by this, so it'll run pretty much like it should. Obviously it'll be a little bit more compression, so maybe a little bit more power out of it, but should be a good solid running motor. The sleeves look great. They're all really, really nicely finished. So the head gasket should seal beautifully, and everything looks ready to go. So this is it for the machining of H22. Next step is to clean it thoroughly, get all the shavings, oil and grease, everything out of it, and then assemble the motor and install it in the car. So there's still a lot of work to do yet, but pretty soon this thing will be back on the road and running down the road. I'm excited about it. I hope you enjoyed seeing some of these machining techniques that maybe you haven't ever seen before, and, you know, seeing the installation of these sleeves in a motor like this. I'll show you more as we develop more into it, and as we get this motor built and get the car running, I'll post some more videos of that. Okay, thank you.